Hi, once again with a new video. I'm Viraj and this is my YouTube channel Match by Viraj. I've been doing a series of videos under Circle Theorem. Today I'll be doing the last video of it. And if you could not see my previous tutorials, you can go to the link over here and get to see them. By the way, today I'm going to teach you all alternate segment theorem, two chords intersecting inside a circle and two chords intersecting outside the circle. Remember, what I'm teaching you through YouTube, you can use them for London syllabus, the Cambridge syllabus, the local syllabus or any syllabus that you are doing. Alternate segment theorem. A lot of children get confused in this theorem. The theory behind this is simply angle between a chord and the tangent. Angle between a chord and the tangent is equal to the angle in the alternate segment. To the angle in the alternate segment. Right. So if that is the case, in here, it should be equal in this side as well. Right. Since a lot of children find it difficult, let me go for the proof of it. When you know the proof, it should be really easy for you to understand and use it where you need it. Right. Now we know that this is the center of the circle. If I drew two lines and mark these points as A, B, C, OA and OB, they are radii, which makes the triangle OAB an isosceles triangle. Therefore, this is going to be, let's assume that this angle is having a value of x. Therefore, this angle will also have a value of x. Remember in the previous tutorials I told you that when a radius is drawn to the tangent, the point of tangency, the angle produced is how much? 90 degrees. Fine. Let's mark this angle as 1. So we have one equation, x plus y equals 90 degrees. Then I am going to redraw another line which bisects the angle AOB, which bisects the angle AOB, which makes this particular angle, let's mark this as D, which makes this angle 90 degrees. Right. Let's mark this as W. Now, what is it that we know? We know that angles in a triangle add up to 180. Angles in a triangle add up to 180. By consider triangle ODB, I can say that W plus X plus 90 equals 180. That is W plus X equals 180 minus 90. W plus X equals 90. Therefore, I come up with two equations. How many equations? Two equations. Now, I have two equations. Let's do the calculation. This means that x plus y is equal to 90. Also, w plus x is also equal to 90. Now I can write x plus y is equal to w plus x. By equating the two equations 1 and 2, I can cut off the two x terms, which gives me y equals w. Right. Y is equal to w. Now previously, remember I mentioned that I am bisecting the angle AOB. When I am bisecting the angle AOB, not only this angle, but this angle also has the same value, which we can mark it as W. Now, from alternate segment theory, we know that this angle, what is that? Angle between the chord and the tangent should be equal to the angle in the alternate segment, that is this angle, right? Do you find any similarity or any combination between these two angles? You should. What is it? This is simply what is it that we have? Twice angle theorem, or angle at the center is twice the angle at the circumference. Therefore, if this is 2W, this is W. If I mark this as W, I have come up with Y is equal to W. Therefore, if this is Y, this is also Y. This is a very simple explanation that you all can understand and use. There's nothing new. I've taught everything in the previous tutorials as well. What is it? The chord I have taught you all. The tangent I have taught you all. Angles in an isosceles triangle I've taught you all. That this radius touching the tangent produces 90 degrees I've taught. And twice angle theorem. See, as I always say in maths, all the theorems are interconnected to one another. Chords intersecting inside a circle. This is a pretty easy theorem. Let's see. Now, how many chords do I have? I have two chords, namely the chord AB and CD. These two chords intersect at a single point, which is P. Therefore, I can say AP into PB is equal to CP into PD. This equation will literally give you all the answers and the values of the chords that are within the circle. Chords intersecting outside the circle. Here I have two chords, A, B and CD. But unlike in the previous theorem, the two chords intersect outside the circle. Chord AB is extended to P and CD has also extended to P, and both the chords intersect at point P. Now if I am to write the equation, it would look like AP into BP is equal to CP into DP. Now, as children, you all might find it, a bit tricky to keep this in mind. Let's try to figure out an easy method. You can stretch the hand, bend it back again from the elbow. Similarly, you can write AP into PB, that is stretching your hand and bending by your elbow, which is equal to CP into PD. CP into PD. The only difference that I have made is just changing this to letters. It will not make any difference in the final answer. This is only for the ease of understanding and keeping it in your mind. Therefore, we can use either of these equations and both of them are correct. Hope you understood the tutorial today. Just in case you missed the previous ones, the links are in the description below. If there's anything that needs to be cleared or a new lesson to be taught, please make a comment below. Stay tuned for new videos and subscribe. Maths by Viraj.